Hello, I'm Lloyd Kapang, and this is my individual contribution to the group project work for real-time animation in VFX. So let's get started. So during the very initial stage of this project, our first task was to collate together a bunch of reference images into a mood board so we could see what type of environment fit our themes and ideas that we were trying to convey. And I personally looked into some desert environments and collated that into a mood board, as you can see here. However, later on in the week, we decided that we wanted to go for a Japanese cult-like environment. So because we're pretty grounded on using this idea of a Japanese environment, I decided to do some VFX concepting early on. And I tried creating a bunting line asset within Houdini. One negative about this is that I learned very early on that concepting and prototyping of VFX isn't something I should be looking into this early on in this stage, and the main priority should be to develop a hooking and engaging storyline. It was still really good practice since I learned how to create an extremely performance friendly asset, as it is just a curved line that is animated via the points being affected by a mountain node. Um, and I just added some polygons onto it, and it gave this illusion of a bunting line that was moving from the wind. Based on the feedback we got last time, it was clear that we needed to develop the story further if we were going to make it engaging for the audience. So what I did was create some early iterations of storyboard panels, and the main goal here was just to get an understanding of how the story flowed visually, as well as what kind of dynamic poses and movements we wanted Echo to be in. The storyboard panels that I created also helped out the team because it would just keep everyone on the same page and clear up any misjudgments they had about how the story would actually flow. During the early storyboard stages, I also needed to visualize Echo's backstory, as it would give the audience an explanation of why she's there and what she's looking for inside the temple. A lot of these storyboard panels didn't make the final cut, but it does show the significance of storyboarding because these three panels right here did make the cut, which showcases that you always pick out your best ideas and you just keep developing the ideas from there. From there, I developed the introductory storyboards further and made it visually clear through the panels that Echo's cursed arm was linked to the doll inside the temple, and that was her reason for being there. The refined storyboards would inform our animatic and help us during the motion capture week, and I had drawn and developed three sequences where we see Echo's cursed arm being affected as she walks up to the temple, and then we have another shot of her walking through the main doors, and a POV shot of her looking through the mask, seeing safe places to go and traps. And then we have another sequence where the curse is being lifted from her arm as she crushes the doll, whilst traps being activated as she has to run away back outside of the temple. During this time, I developed proper naming conventions for our shot lists, and this would make it easier for our group mates to find when we needed the mocap data to implement it within UE5. During motion capture week, I was assigned the task of characterizing Echo, and this is important as I'd be able to retarget our motion capture data onto Echo's rig. Using Motion Builder was an advantage as well, as I'd be able to map Echo's rig using the human IK template that comes with Motion Builder. With the motion capture data acquired, we wanted to test out and create a working version as early as possible. So I was assigned the jumping over the pit scene, where I would be able to test out the camera angles and test the timing of our animatic and see if it was feasible. As you can see, both of these sequences looked very rough. The timing of the camera changes looked off, and the camera angles just weren't compositionally pleasant. But as this was a working version, an early working version, it meant there was lots to improve and lots to get feedback off of. Now that we had an early working version of our project, I was able to develop visual effects, and I started off by working on a snow blizzard system in Niagara. And the reason I chose this over Houdini was because Niagara allows me to fine tune and control how the snow particles behave and how fast and what direction they move at. Whereas if I was to do it in Houdini, I'd have to import and re-import every time I'd need to make changes to the snow particles. So with this particle system, So with this particle system, you could change how dense or how sparse you want the blizzard particles to be through the spawn rate. You could also change the scale and size of the snow particles via the scale sprite by speed. So however fast it goes determines how big and small the particles will be. And to make it move in a certain direction whilst having random movements, I layered on top a vertex force and a curl noise force. That way you could get that blizzard look. One of the weakest aspects about this blizzard system was me not being able to incorporate a mist system as well. And that's because when I tried creating one, it just didn't look right, and to me it looked like steam. The next VFX I worked on was a rock falling and breaking asset, and I was really proud of this as it met my goals of being able to develop my technical skills within Houdini, as well as learn how to make procedural tools that overall assist the workflow. And this node system allowed me to put any asset in uh, and fracture it very easily and procedurally, and be able to export it as an FBX for ease of download for my teammates to use in Unreal Engine 5. So how this node graph works is that when you put an FBX file in, you can transform it as much as you want. Let's say we do this, we scale it like that, we move it around, and we put it through the node graph where we create fractures, and we put copy to points through it so that we're able to tell where the Boolean fracture we want the. So how this works is that we take our asset, our FBX asset, and we put it through the node graph where we can just transform it as much as we want. We can rotate it in any axis we want, and then at this point we can copy to points a bunch of grids with mountain nodes on it. And the reason why it's procedural is that it just scatters it on the asset, and that way you can add any asset and it will automatically scatter the points. And you can change the global seed as well to change where the fracture lines are, and through a Boolean fracture node we can fracture it. And then also we can make a proxy mesh where it's a low res mesh, and then that will be used to simulate it. And then from there we can see that we can get many different variations of this. So for example, if we change the scatter point, we get different ones every single time. We can change how many scatter points there are, we can change the global seed, all for different variations. And the reason it's running super fast is because we've poly reduced it. And from there we can take our points that we've from the proxy mesh, the low res mesh, and then we can transform that onto our high res mesh, and then that's when you can export it out into labs. The final thing I worked on was improving and creating the final working version of Echo jumping over the pit scene. And you can see that I've built up more anticipation before the jump to keep the audience engaged. As you can see, I've also used a combination of a low angle shot and a high angle shot to really emphasize the depth and scale of this pit. And with more anticipation shots, we really build that tension just as she jumps and lands. And yeah, that was my contribution to this group project. Thank you for watching.